All right, and we are live. Welcome to our next session. We're going to go through some Snapcraft examples and give you opportunities to see the thing live. We'll give some live demos of how to use it, explain what we're doing as we go through and build the YAML, and we'll show how it installs and runs and talk about some interfaces, and it'll be a fun time. Sergio, you want to start us off?
Okay, yeah. So, reintroducing ourselves for those who have been following this core topic all day long and yesterday. I'm Sergio, and I'm basically working on Snapcraft from day start to day end. And with me here is Kyle, who works with me as well on Snapcraft, and Zygmunt, who is basically focusing on the Snappy code base itself and specifically interfaces, and it's the fun part that is binding development workflow together. Uh, so to actually get a good start on, so what we're going to do here today is first Kyle's going to start a project, maybe from scratch, maybe not. It's up to him. But he'll basically guide you through what he's doing, and create a couple of the the building blocks for Snapcraft to create snaps. So a snap is basically a product you create. The product you create is something you want to deliver to people, just like you would do on any other platform and ecosystem. That can be, well, given that most of the people here work on open source, it could be something that you just package, which is basically something you just fork and put somewhere and maintain, or it could be your own thing. And specifically, I guess it makes it easier if it is your own thing to put something there without needing hand-holding from other people. Um, the so when Kyle grabs the when Kyle starts his project, he's basically going to Snapcraft init a project, and then he's going to start with write a couple of metadata that ends up in the snap to give it names and authors and a bunch of things to make it bindable and uh, well, yada yada that every package has in the end. And then he's going to go in and write parts. Those parts are basically the sources that he's going to refer to build stuff, and those things are going to be built out through plugins that I don't know which plugin he's going to use, but there's going to be a plugin that's going to drive the way those sources are built, and those plugins go through a life cycle, which is basically pull, build, stage, and strip. Depending on the project he chooses, he might use the after keyword for a part, which basically tells the life cycle in which order to build parts and how to use the shared artifacts they use, which are basically shared through this staging area, which is a stage directory inside the project. With that brief introduction, I guess, Kyle, do you want to go ahead and start out?
Sure. All right. So let me figure out this desktop sharing thing here.
Okay, while you do that, I'll explain one more thing. All snaps are this adhesive thing. It's just one thing, and it's all inside the snap. It has a lot of security stuff that holds it together and makes it not, I don't know, expand itself into these weird locations. The the way you access whatever you want to expose in a snap is by declaring apps, and those apps basically bind it in your commands to the outside world. Aside from that, you also get to declare a desktop file, which is another way to expose those in the graphical way, those commands in the graphical way. And that said, Kyle, go ahead.
All right. You guys can see 3 windows on my desktop?
Yep.
Okay, very good. So I wanted to come up with an example to show you, for a desktop app, one that has a GUI. Until fairly recently, Snappy was really focused on just the Internet of Things. So the addition of GUI support and running on the desktop is new with 1604. So I wanted to show you one of those, and I figured what better example than one that someone else wrote for me, which is a Qt example. So the perfect one, I thought, was their application example, which is just a text editor. I'll just show you what it is here real quick. I'll just build it locally. And go away. So this is just one of the Qt examples, the application one that you get with the Qt SDK. I'll just build it and show you what it looks like running on regular. This is actually 1404, but you get the idea. It's just a simple text editor. Nothing really special about it, but it is a GUI. So let's start with that. So what I did is I copied that code in here, and actually the first thing I'll show you is this. So this uses Humic, which actually the experienced Snapcrafter will notice it does not have a plugin to support it inside upstream Snapcraft. So I had to write a local plugin to deal with that, and I'll talk about that in a second. So here is the profile from the Qt project. I did change it a little bit to change the install path, but you'll notice here that it has an install rule, or rather it will generate one in a make file that's generated. That's important for Snapcraft because otherwise it doesn't know what you want in the snap. It's not going to put all of your build artifacts in there, right? All your object files, etc. You have to tell it what you want to install, which is what install rules are for. So that's an important requirement. If you don't have that in whatever upstream you're trying to snap, there are ways around it. What I do suggest is trying to get the install rules. Make the font bigger. Boy, good question.
Control Shift plus 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 plus. Is that num terminal? Control Shift plus 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 plus.
There. Does that look better?
Two more times, I guess, just so we avoid conflict. There we go.
Sorry about this. Normally I'd share individual windows, but I have to show several, so I figured this would be easier. All right, so I hope that's more readable. So here, I'll show this again in case people couldn't see it. So the install rule. If you're trying to snap an upstream that doesn't have install rules, I do suggest trying to contribute those because they're kind of important for projects. But if for some reason you can't, there are ways you can do this, mostly by making a local plugin that copies stuff specifically rather than relying on a build system to do it. I'm not going to talk about that here because fortunately I have an upstream that does it for me, but that's an important note. All right, so I copied all the source code into just a directory that I called source, src. I didn't change it other than that profile to add the to make it go into bin instead of an example subdirectory, which was yucky. And I wrote a snapcraft.yaml. So I'm not going to do this. So normally what I do is run snapcraft init, which creates a YAML just like this. This is the basic metadata that a snap consists of: the name of the snap, the version of the snap, and a summary and a description, like basically just you could think of it as a title and a description for the snap that you're creating. I took that and built on it. Oops. There you go. And came up with this. So I named it application, which is actually a terrible name, but it's the one that's what upstream is called. So I went with that. I called it version 1. And I gave it a summary and a description. I'm going to skip over the apps for just a second, and we'll talk about the parts instead. So the parts keyword, as Sergio mentioned, is how you specify how the snap is put together. You'll see this consists of only one part, called also application. I could have named it whatever I wanted, but since it's building the application, that's what I'm calling it. It uses the Humic plugin, which, as I mentioned, does not exist in Snapcraft. I'll talk about that in a sec. And it tells it that the sources are contained in the source folder. I also have a build package here. A build package is installed on the host system used to build the snap. So this will not end up in the final snap. It's just meant to be used to build it. Now, some of it will actually end up in the final snap as a result of the fact that my binaries in the snap link to them. I'll talk about that a little more in a minute, but Snapcraft will automatically crawl the final snap and pull in libraries that it thinks you need just by using LDD. Now, the stage package, this was actually a question brought up by Ted in our earlier session. The way Qt runs on separate platforms here is by using system plugins, and those aren't linked in with LDD. They're loaded dynamically, which means the automatic crawler doesn't notice them. So I have to actually have a stage package that includes the plugins so that it actually runs. And this is what I'm going to talk about now. It's after Qt5conf. What on earth is this? This is actually a wiki part. By specifying that I want this part to build after another one that is called Qt5conf that is not specified here, notice I don't have a part called that, then Snapcraft will actually go out to the wiki, which I should have opened, but I didn't, so I'm going to do it now. Go. So Snapcraft has a wiki that it will come and parse for community contributed parts, basically. This is the one. Let me blow up the text a little bit since I know you guys are. This is the one that I'm trying to use. Notice it's called Qt5conf. It has a build package, uses the make plugin, and its source is here. Let's go take a look at it just real quick. This is really what I want to look at. So it has this script in it that essentially sets up the Qt environment to run inside the snap. So typically Qt would look inside, user lib, etc, right, for all of these things that aren't in the snap. They're all nested inside this snap directory, which is represented by this environment variable. And so basically any Qt app is going to need to redefine these environment variables to point it into the snap itself rather than trying to pull in something from the system which isn't there. So that's why it is on the wiki, because it is so generic, and I want that in my snap. So I use the wiki part rather than copying this script in and duplicating that work. And I'll show you what that actually turns into. Well, okay, so you see the script is called Qt5 launch, and I use it right here. So, get this out of the way. All right, I'm going to pause this for a second, and now I want to talk about this Humic plugin. So as I mentioned, the Humic plugin is not upstream in Snapcraft. I plan on putting it there, but right now it's not there. And the way I'm going to put it there is by developing it here. And the way you do that is you create a new plugin inside parts plugins. Actually, you know what? This is documented. Right here. I'm going to paste this into. There we go. In case anyone wants to follow me here. So the parts folder is where things are built, etc. But if you create the plugins directory and add plugins in here, then Snapcraft will actually search here for plugins as well. So this is a way to extend the Snapcraft plugins, which it may not support exactly what you need. For instance, trying to build something that doesn't have install rules. If you can't submit the install rules upstream, then you can make a local plugin to deal with it, as I did here for Humic. So. As Sergio mentioned before, there are a number of life cycle steps that Snapcraft goes through. One is pull, the next one is build, then stage, then strip, and then finally it turns the stripped stuff into the final snap. I didn't need to do anything special as far as pulling, staging, and stripping goes. As you can see in my YAML, right? I already have my upstream source here just in my source directory. If it was on GitHub, then I could specify it here. Whatever, and that would work. That would work the exact same way. But since it isn't on GitHub, I just copied it locally. So the pull step isn't going to do anything unusual. The only thing that I needed to worry about in my plugin here is the build step. So I needed to make sure I ran Humic, and that it worked with Qt5, because by default it actually tries to run the Qt4 Humic, and that's something I haven't messed with a lot. This probably needs some more love before I actually upstream it all. Humic will generate a make file, and I want to run make on it. So here's just sort of a technical detail. Snapcraft does keep track of how many cores you have or how many CPUs you have. So I want to build as fast as I can. So I make use of that here. And finally, make install. So Humic does not generate make files that use destier. They use install root. That's used here to actually install it nested into this parts install directory, rather than trying to install into /bin, for example, which would happen in this case. So now I'm telling it, I actually want you to install into your little part install directory /bin, which will then install. It will then result in a bin directory in the final snap. So now, apps. So now, Snapcraft rather will generate a wrapper that adds the bin folder to path, which means anything in there I can just shell out to. And so this apps key here tells Snappy what application in your snap you want to export to the system. So anyone can call something that's packaged in your snap, but lots of it is going to require environments that are local to your snap. For instance, the Qt plugins are not going to be in /user lib x86 whatever, right, or wherever they typically go. They're going to be inside your snap, and so by default that's where Qt's going to look. So if they try to run your application just straight up, they're going to end up with errors. They need to run with the right environment. So you export that using this apps key. I called it application, and the command to run it uses that Qt5 launch script, which sets up the environment correctly, and then the application binary, which is built as a result of the the Humic plugin. So I add two plugs here. This is where the interfaces come in, the capabilities necessary to actually run this snap. First of all, it requires the Unity 7. Actually, it probably wouldn't. I could have just used the X11 one here. The point is, it has a GUI. It needs to be able to show its GUI. I use the Unity 7 interface here for that. I also use the home interface because it's a text editor. It's of limited use if all it can do is talk edit files in its own confined directories. It's still somewhat useful, but it is rather limited. So I added the home directory there so people can use it in a more general way. So let's actually go through building this thing. So first of all, I'm going to go through each lifecycle. If I just ran Snapcraft by itself, I'd end up with a snap. But I'm actually going to run each step of the lifecycle on its own, so I can show you exactly what's happening. So I'm going to run Snapcraft pull first of all. What this does is it's pulling down all the stage packages that are necessary. It will also install the build packages. I already have that installed, so it doesn't really matter. But this is downloading the build package right now, or excuse me, the stage package right now.
While that pulls, do you mind answering the question?
Oh, please, yeah. If there's a question regarding this, please interrupt me.
So there is a question about build packages and how to make it easier to find out what build packages you need. It's a trick question.
just read it to me.
I'm having trouble finding the minimum set of build packages required to build my snap. Running on clean build for every change is slow. Any tips? I can answer the second part.
I mean, I can answer the second part too. As far as determining what build packages you need, it is difficult because typically the build packages, well, let's see here. I mean, lots of them are going to be documented upstream, right? What's required to build this project, and those would probably be build packages. Other than that, I mean, how do you determine the build packages you need outside of Snappy, right? You build it and it fails, and you figure out what's missing, and you install that, right? In this case, you build it and it fails, and you add it to the build packages. I would suggest iterating on it outside of Snapcraft to determine how to build it before you try actually putting it into Snapcraft. I think that'll save you a lot of pain. As for going through clean build and it being slow, I'm not sure. I mean, clean build's great, but it may not be necessary, particularly for iterating like this, because pulling stage packages or whatever can take some time, and the clean build's going to have to run it clean every time. You might want to actually just use it normally, and instead of repulling every time, cleaning and then repulling, just clean back to the build step, so that you don't repull everything every time, or whatever step you're working on at that time. Sergio, do you have anything to add to that?
Yeah, there's two other paths to take. One is that we add a capability to clean build to say keep. So if it breaks, you get to keep the broken pieces. And you can then log into that environment and check what's missing. The other one is just create an empty container and run Snapcraft from there and see what's missing and iterate there.
I also have a suggestion that one I used a couple of times. It's actually from back from Debian time. So there's apt cache ng. I'm not sure if it's easy to plug it so that it's actually used by default by Snapcraft, but lots of building, and just like the slow part wasn't the building, was just getting the dependencies pulled and then installed. So I was working with apt cache ng, so that those dependencies would be essentially available for free offline. And I also was using just TemperFest for having ultra-fast builds. So that setup can actually, if you like warm up the cache, you can actually work offline very, very quickly. So with some care, you could probably do this with Snapcraft as well.
Great. So we have 3 different answers. Good answers.
All right. Any more questions, or shall I continue?
Well, there's one more, but it's not really related to building. But yeah, we can look at it. Once you have a final snap, how do you look at the contents? People say that they can look at tar files and deb files with the archive manager, and that's not possible with new snaps. I guess the answer to that one would be
on SquashFS.
On SquashFS,
I can show that. I'll show that. Remind me when I have my snap, and I'll show that real quick.
Yep.
All right. So I have this pulled. What does that mean exactly? Well, so if I go into the parts directory, you'll see I have the plugins directory that I created for my local plugin. I also have a directory for application and Qt5conf. So Qt5conf is that wiki part that I pulled down. So let's just take a look at that real quick to get that out of the way. You'll notice that it simply has this Qt5 launch script in the bin directory, which is exactly what I wanted, and I can use it from there. And that works just because of the way the wiki part is set up. If you could contribute your own wiki part that does something differently, but the way this one works is it puts that script in the bin directory. So let's go check. Sorry, go ahead.
I just want to make a quick interruption there. It might be overstated. You just ran pull, right? But
yes.
That wiki part even has installation in there. What does that mean?
Oh, yes, thank you. Do
you want to explain that, or?
Yeah, I'll explain that. So since in the YAML, I used this after keyword, and I said, so basically this is saying, hey Snapcraft, I have this part that I want to build, but I want to build it after you build the Qt5conf part. So what Snapcraft does there is it actually will take the part that you put in the after keyword. Notice this is a list, so it could be a list of parts. It would take each of those parts and make sure they were completely staged before starting work on the part in question, which means it goes through pull, build, and then stage before it even bothers pulling the part that you're actually trying to build, which in this case is application. That's why, actually, if you look in the stage directory, you'll see the Q5 launch script already there because it has been staged. And that will work for anything. So the way the after keyword is typically used is if you have, some part. Let's say you have a boost part, and you download the boost headers, and then you have another part which needs the boost headers. Well, then that part you just say build after boost, and Snapcraft will make sure the boost headers are available in the stage directory for that part to be built. Does that answer the question?
Well, no one asked the question, but yeah.
You asked the question. Does that explain it well?
Yeah, it does explain it well. Yeah, I just wanted to clarify that just so people weren't confused.
Yeah.
And also just add one more thing, that the parts directory, each part in the parts directory is considered private for that part. You shouldn't intermingle or try to say this part should access this thing inside this part path. That's something that should be private in the sense of the life cycle. And if you need to share something, it has to be staged. That's why everything goes. If you have a dependency of this style, it will have to be staged first, and then the other part can actually start its life cycle.
Yeah, great point. Thank you. All right, so let's take a look at the application part here. So what did it do? Well, if you look in install here, it actually this is the stage packages. It pulled down the stage packages and unpacked them here. Now I have one stage package here which includes the Qt plugins and stuff. For instance, let's see, where is it? Okay, so you can see all the plugins that were pulled in, and that's why I have the stage package. There's also, oopsies, you can see that this source symlink goes back to the original source that I gave you. So that's part of the pull step as well. So now, the part has this source directory that is pointing back to my local source. If I had a remote source, that source directory would actually just be, the remote source. It wouldn't be a symlink at all. So that's the pull step. Now I'm going to build it. So now you can see it's building. Doesn't take that long because it's not that complicated of a application. And now if I look back in the parts applications, well, I mean, you can just look in the build here. You'll see all of the build artifacts, right? You got the final binary application, you've got the various object files here. And if I look in the install directory, I have this bin folder with my application in it. That would not have been there had the install rule not put it there. So that's important to know. And the install directory of each part, this parts application install or parts Qt5 install, is where each thing is pulled from. So the build directory is not used to pull these things into the final step. All right, now I'm going to stage it. What the staging does is, so up until this lifecycle step, each part is separate and should not, there should be no crossover, as Sergio said. These are private steps. The stage step is the first part, or first time rather, where these parts are actually pulled in together into the same directory called the stage directory. Now, Qt5 conf was already staged. You can see that here. Skipping stage it already ran, right? Snapcraft is making sure that it was already staged because it knows that the application depends on it, but it was already staged because of the pull step that we ran. So now if we look in the stage directory and look in bin, we have two here, application and Q5 launch. Q5 launch came from that Q5 config part. The application came from the application part. And they go together just fine. Now, if they, for some reason, tried to stage the exact same file, but they had different contents, right? You'd run into some problems here. I won't talk about that here, but there are keywords that would allow you to get around such things. Stage keyword specifically. And now we have this snap directory, which is completely empty. How we get things to there is we use the strip step. The strip step will essentially copy everything from stage to strip. It's a little more in-depth than that because there can be filtering involved. But one of the really important points here is it will then crawl the strip directory looking for ELF files, run LED on them, and pull in the libraries that they link to. So now I've got all these things here. It also generates this meta directory. This is where rubber meets the road, or rather, where Snapcraft meets Snappy. This is where it generates what Snappy needs. So if you look at the Snappy documentation, you see the stuff about snap.yaml, etc. You don't need to deal with that using Snapcraft because it generates it for you. You could also do this yourself if you wanted to, but we try to make it a little bit easier with Snapcraft. Let's take a look at that just real quick. It should look familiar. You see the apps that we added. There's an architecture for the host that we built on, and the other metadata that is pretty much a straight-up copy from the Snapcraft.yaml. Sorry, it sounds like my son is crying. Also, something important to note here, Snapcraft generated a wrapper for us. Notice it, command application. It's application because that's what we named our application right here, or our app right here. So what this does is it actually sets up more of the environment for us. So it prevents us from having to do it ourselves. So I mentioned before that it adds snap bin to the path. Well, this is how it does it. It generates this wrapper for you, or snap user bin. It also sets up the LD library path so that you can run with libraries that are in your snap instead of trying to use the ones that are only available system-wide. And a lot of this is automated. That's why you see a couple of the ones they'll come from. They depend on the plugins you use, etc., or the libraries that were pulled in as a result of the crawling. And then finally, it runs the app that you gave it. Right. Sergio, am I missing anything else here?
Nope. Just wanted to say that this wrapper thing is an implementation detail. It's not really something you'll be facing every day. Right?
Yeah, true. All right. So finally, I want to create the actual snap, which is going to take the snap folder and turn it into a SquashFS-based snap. That'll take just a sec here. All right, now I have my snap. I want to show it to you. All right. Oh, right, on SquashFS. Okay, so I have the snap. How do I look at what's inside there? Well, it is a SquashFS file system, which means you can use all the SquashFS tools on it, such as unsquashFS. So I'm going to use -L here. And you can see all the files that are in here, just like what dpkg-c, I think, would give you a list of everything that was in here. You can look at it all right here. You could even mount it if you wanted to. Ooh, boy. The command line for doing that escapes me, though.
Just mount. Don't worry about it.
Mount it.
Yeah.
Just wanted to mention that option existed.
Yeah, you can totally mount it and look at it. Note that these are read-only, so while you can mount them, you can't modify them.
In the future, we'll also have snap try, so you'll be able to do snap try from the stage directory or snap try from the snap directory directly, and the Snappy system will make sure that everything is hooked up as if it were a real snap, and then you'd be able to, for example, in stage, you'll have a bunch of things that will be in the final snap, like I don't know, maybe debugging symbols and stuff like that. And in the snap, you'll be able to iterate faster, basically, instead of having to create the SquashFS every time. Because the bigger your snap, of course, the longer it takes to SquashFS this. And once you do this, you can iterate, and directories will be updated, so the snap will be updated, and you won't need to go through this cycle again and again.
Right,
Sorry.
and you know the current way to test it right now is to install it, right? In which case, the thing that you installed is read-only because it's a Squash FS now. There are some ways around that. You can use overlay FS to modify it temporarily, but it's not the workflow that is ideal. The snap try will make that so much better. All right, so I wanna test this out. So I'm gonna send it to my virtual machine here, where I have the Xenial desktop. Make that go away and pull this up. Unfortunately, I don't have the guest editions installed here, so I'm actually gonna stop presenting and I'm gonna set it just to my VirtualBox window. All right, all good? Can you guys see my VM here?
Yeah, I can.
Okay. All right, so now I just SCP'd this snap over to my Xenial desktop. You know, if I was actually doing this development on Xenial, I wouldn't have to do this, but I'm still running 1404, so that's why I'm doing this. So see, I've got Ubuntu Core here. I think by default I wouldn't have that installed either. If I had just installed Xenial, it would be pulled down the first time I installed something. But I've been playing with this, so I'm going to install it. Oops, there we go. All right. So what did that do exactly? Well, since I exported an app from Snappy, it generated a wrapper for me in Snapbin. What does that look like? So this is the side effect of having the apps keyword with the application. So it sets up the Snap specific environment. So you know what directory, where is the Squash FS mounted, etc. And then it runs the actual app with Ubuntu Core Launcher. I just realized that I'm using like all the time, so I'm going to hustle up. Ubuntu Core Launcher is what confines everything. So that is in my path, but I also have, oh darn it, I forgot to talk about this. I ship a desktop file in this snap, which is named this, and you can see it launches. It's not very pretty because there are some theming issues I haven't worked out yet, but it does work. One thing I want to talk about real quick, let's say I try to save. I mentioned that I added the home interface. However, as you can, the home interface does not automatically connect because there are some security concerns there. So while my application requested it, Snappy did not grant it automatically. So you can see if I try to save this, you know, in my home directory, I can't. I don't have write access to this. I don't even have read access to this. You can see there's nothing here other than the thing that I can actually write to. But I can say connect the plug, the home plug from my application to the home slot from Ubuntu Core. It's small for me to see. There we go. Now you can see it's actually hooked up. And if I hit save again, I can actually access the home directory. I guess that's pretty much all I wanted to show. Sorry for taking so long, guys. I didn't realize. Is there anything else I should talk about there?
It's the expected
What?
time I thought it'd take. Fine. So what Zygmunt and I are going to show is just for a variety's sake, something a bit more different, but the walkthrough is perfect. Just going to take the opportunity to answer one more question that's hit, which is no snap remote. No snap remote. Snap the snap command should eventually gain the ability to install to remote locations through its REST API. So you'll be able to just do that whenever it's possible.
So you want to go first, or you want me to show the demo I have? So
sorry, go ahead, Stephen. Go ahead yourself.
Okay, so I'll quickly do this. Oh, sorry, wrong icon. Let's try to share my screen as well. Do you guys see it? I hope you do. So this is a bit different. So unlike the previous example, I'm not going to focus on building the actual code, because I'm going to show you a game. And games are typically, you get them from somewhere else. They're pre-built. You just want to put them in a snap, so they're a bit more confined, and you can easily install them later. You don't have to worry about, if it's like a game using Wine or using something else, or DOSBox or something else. So this particular game is actually freely available. It's The Flight of the Amazon Queen. It's a point-and-click adventure game for my youth. Perhaps I actually didn't play this particular game. So I'm going to show you the Snapcraft file and cover maybe some other things that I found interesting. So apart from the typical stuff we already covered, like name, version, description, all this stuff, I have a couple of extra parts which I added because none of the things I was trying actually worked. While doing this yesterday, I found a bunch of interesting bugs. Some which were already fixed, some of it are still in progress. I've added busybox because busybox gives me all the useful shell commands without having to put tons of stuff into my snap. I also added GDB so that I can run my snap within Snappy with confinement, and actually I can poke around with GDB. The game itself is actually very simple. It's a single file. It's like a big binary. I'm not sure what the format is. That's ScumVM, the big open source game engine that implements dozens of different game engines for all the nice old games supports, just interprets. It just looks inside, knows how to handle this particular game. So I took ScumVM directly from the Snap package. So you can see this here. Sorry, you can see this here. The ScumVM part is just using stage packages. So I just took it directly. Same, actually, all of these are using stage packages directly. The game itself is copied right here, so I didn't have to copy it, but actually you can also get it from stage packages. I just wanted to experiment more. So one thing I want to show you quickly before I show you the game is that after I've been experimenting and I hit a couple of roadblocks, I ended up just getting the sources of the Debian packages that I were using, and built them locally with additional debug symbols, and just stick the additional libraries inside. So inside my Snap directory here, I have a huge, maybe a user lib. I have a huge version of a couple of the libraries. So for instance, I think libsdl. This one is, the wrong one. This one is 2.5 megabytes. And actually, this one I built locally and just copied it in. And the nice thing I want to share is just like, I can just say Snapcraft. Let's see. It's difficult sometimes. Snapcraft. Snap. You package the Snap directory without really building anything, without doing anything. This allows me to. This is like a poor man's version of Snappy Try that we already talked about. Allows me to tweak one little detail, just one isolated detail, and put everything together. The other thing I want to quickly show you is the setup directory. We already covered this a little bit, but specifically I want to show that the desktop file, how the desktop file to work, and some behind-the-scenes details of what Snap is doing to it. So icon file.
Sorry, Zygmunt, let me interrupt real quick. I should have talked about this in mind, but what he's about to talk about is why the desktop file worked for me. So, sorry, go ahead.
Sure. So the desktop file is actually processed by Snappy. We look at, so let me quickly show it while I talk. We look at the file, we parse it, we get rid of things that are not safe, like try-exec and a couple of other things, so we don't accidentally allow people to run commands in inappropriate places. And we also expand the $snap curly brace into the same variable that exists in the runtime environment later. So this is a trick. Right now, it's the only way to do it for getting the icon to work. I just want to show this because everyone asks this question. This is how to get the icon to work. You have to use this. We're going to make a better version, hopefully, so you don't have to really know this implementation detail, but that's the thing you want to do right now. So quickly, just Flight of the Amazon Queen, and shows up right away. It has the right icon. It actually works. I'm going to run it quickly. It currently runs in development mode because we don't have a complete Pulse Audio interface, and some of the bugs I've uncovered are not fixed in the version. I'm actually running Snappy 202, so the same one you can get in 1604. So this is just in dev mode. Since everything I've made here is actually freely available, I'm going to share the snap so people can play with this and experiment with this and maybe adapt this. Because the nice thing about them is the same dozens and dozens of games. So you can take the same Snapcraft file and just replace essentially the game part. Just stick the different binary of your game, whether it's people have or have bought have bought all those older games from various sources. They have their binaries on their disks. They just want to run them on Linux, on Ubuntu. Just stick those binaries in, tweak the ScumVM executable command line here, and it's easy to just swap a game in and have a different game running under Snappy. And one more thing I want to show is the plugs. So right now I'm using Unity 7 and OpenGL. And OpenGL is there because ScumVM can actually use OpenGL as acceleration, so I just kept this in. But perhaps we're going to add sound support to Unity 7, or perhaps there's going to be a dedicated Pulse Audio plug that are going to allow your app to run in confinement but still have access to sound. I think sound is the last big thing that is under development. It still has some open issues that we're working on. So that's roughly it. And the snap itself is, how big is it? It's pretty big because it has all the development and debugging symbols. But if you just build it directly, it's roughly half the size, I think. So that's it. It's a very quick demo. I can also run it from the command line. Flight in Queen. And that's a good way to show one more thing. So Snappy and Snapcraft have this nice feature. When you have a snap called foo that has an application called foo, you can just, the executable you run on the command line is just foo. So if you run it, that's just directly the command. If you have additional apps in your snap, like I have BusyBox, I can just say Flight of the Amazon Queen, which is the name of the snap, dot the name of the application, which is BusyBox, and run it. And this is BusyBox running with Snappy confinement in advisory mode right now, but still. And I can experiment. I can pull around and see what's going on. I also have GDB in here, which is very useful for debugging. So that's all I have. If you have any questions, I'm glad to take them now.
Great. And in the meantime, I'll quickly share my screen and show something as well. OK, so here I have this Visual Studio Code thing running. So what's interesting about this is that this Visual Studio Code is actually a snap. If you see this, I have a snapcraft.yaml with a name called Visual Studio Code. As Zygmunt mentioned, I have an app called Visual Studio Code, so I can run it through the command line just by saying VS Code. This is my command, just run bin code OSS. These are the plugs I have. And I also have this interesting one called shell here, which basically just runs bash, so I can just play inside the confined environment with the same plugs that are assigned to VS Code. It's sort of like a trick I have to play around. Then as parts, I actually used the Node.js plugin, but I extended the Node.js plugin to accept gulp tasks. My gulp tasks are basically just implementation deal here, where I just npm install gulp the development dependencies, and then I just run gulp against those tasks. I also created a specific task called prepare snap, and that prepare snap basically just goes over the whole thing, just like there's a prepare deb. I sort of mimicked that, but used Snappy specific paths. I also created a wrapper, which goes through Snappy specific things. And as you can see, the most important thing I had to fiddle with was font config, because I'm using the Debian packages. I intend to compile font config myself and provide it as a part eventually, so it's easier. And as you can see, this is fully translated, because I don't know if you noticed, but some people may not understand these menus. And that's it. So just in time. If there's any questions, I guess we just are going over.
We've got a couple minutes for them. I mean,
like 30 seconds.
We can also answer more questions on the Snappy Freenode IRC room.
Great. I saw the message saying this session has ended. So thank you for your time, everyone, and thank you, Zygmunt. Thank you, Kyle, for sharing.